Welcome to Department of Geology, Shivsagar University. We are starting a new video series on paleontology. This is our first video, and in this video we are going to discuss on the basics of paleontology. So let's get started. The term paleontology came from the Greek word paleos means ancient, ontos means life, and logos means study. Therefore, paleontology literally means the study of ancient lives. It deals with the organisms that lived in the past geological ages and whose remains are preserved as fossils in rocks. The term was coined by Ducrot de Blainville in 1825 and later introduced into geological literature by Fisher von Wellham in 1834. In biology, we divide the study of life into two broad categories: neontology, which studies the living organisms, and paleontology, also called the paleobiology. It studies the extinct organisms and the past life forms. There are three branches of paleontology. Firstly, the paleobotany. It studies the fossil plants, and a specialized branch of it called palynology. It studies the fossilized pollens and spores. Secondly, paleozoology studies the fossil animals. It includes both invertebrates and vertebrates. Thirdly, micropaleontology, which deals with the microscopic fossils such as foraminifera and ostracods. Paleontology is important for several reasons. Firstly, it provides the evidence of evolution. Secondly, it helps the stratigraphic correlation of rock layers. Thirdly, it is extremely useful in oil and coal exploration. And lastly, it allows reconstruction of the past environments, climates, and ecosystems. Let's talk about the historical development. People from long back, as far as 6th century BC, like Xenophon and Herodotus, they have observed fossils in various rock types. However, true nature of the fossils was not clearly understood. Later in medieval period, people described fossils as figure stones. Avicenna proposed the plastic force theory and suggested that the fossils were formed within the rocks. Later in Renaissance, Leonardo da Vinci correctly suggested that the fossils were remains of once living organisms. So after that, people gradually understood the science behind the origin of the fossils. So in 1699, then Nicolas Steno, he established the basic principles of the modern stratigraphy by recognizing the superposition of the sedimentary strata and the significance of the unconformities. Robert Hooke studied microfossils, and William Smith established the law of faunal succession, forming the basics of the biostratigraphy. Later in 19th century, which is also considered as a golden period of paleontology, Cuvier developed the comparative anatomy, and Lamarck proposed the early evolutionary ideas. Like that, in 1859, Charles Darwin revolutionized biology with the theory of evolution by natural selection. Later in 20th century, paleontology investigated with genetics. Micropaleontology developed rapidly, and the industrial application expanded, especially in petroleum geology. So the phylogenetic and evolutionary studies became more refined. So this is all about the historical development of the study. In India, paleontology began in early 19th century. The Geological Survey of India established in 1851, and it played a major role in fossil studies. Many fossiliferous horizons have been identified, like the Thin Himalayan belt, Kashmir, Spiti, Himachal Pradesh, Garhwal Himalaya, Sikkim, Arunachal Pradesh, Kutch, Narmada Valley, Tiruchirappalli, Coromandel Coast, Jaisalmer, Rajasthan, etc. There were many important contributors like J. Warren, who studied the petrified fossils, H. W. Vesey, who studied on the Deccan fossils, F. Stoliska, who studied on the Cretaceous fossils, and especially the Birbal Sahni, who is considered as a pioneer in Indian paleobotany and for his study on the Shivalik mammal fauna. Institutes and organizations like Birbal Sahni Institute of Paleontology, Paleontological Society of India, ISM Dhanbad, Indian Museum, Geological Survey of India, they are generating many informations on paleontology and have been doing research on these fields. Now let's come to the definition of the term called fossil. The literal meaning of fossil is to dig up. However, in simple words, we can define it as the remains of prehistoric plants or animals preserved in rock layers. Lamarck defined the fossils as the remains of plants and animals which have existed on Earth in prehistoric times and are found preserved in sedimentary rocks or superficial deposits of the earth, not only mostly as petrified structures of organisms but also whatever was directly connected with or produced by these organisms. So in other words, a fossil can be described as a unaltered, altered or partially altered remains of prehistoric plants or animals, or the evidences of their biological activities that are preserved in rock. There are many different types of fossils that we will discuss in details in our next video. But for now, fossils could be petrified hard parts, impressions, mold and cast, and traces of biological activities that also known as ichnofossils. Fossils provide information about shape and size, appearance, and the activities of the ancient organisms. And the preservation depends on the burial conditions, chemical conditions, and diagenetic processes. Soft parts are rarely preserved but can occur through freezing, amber, mummification in bogs, oil pools, and in salt inclusions. And the hard parts composed of silica, calcite, chitin, or calcium phosphate are more commonly preserved, and the example includes shells of mollusk, brachiopods, arthropods, etc. Sometimes external molds represents the outer impression. Internal molds form inside the shell. Casts are natural filling of molds. Stickerns are internal stone cast. Ichnofossils are trace fossils such as footprints, tracks, trails, burrows, and the coprolites are fossilized excreta. Fossil eggs and nests are also found. So the process of fossilization is the process by which organisms are converted into fossils through petrification, mineral replacement, or chemical exchange. Essential conditions includes rapid burial, isolation from oxygen, fine-grained sediments, suitable water chemistry, protection from scavenger, and the study of burial process is called as taphonomy. Permineralization is the process of mineral filling the cavities. Replacement means molecular substitution. Recrystallization is the change in the crystal structure. Carbonization is concentration of carbon, and it is very common in plants. To conclude, paleontology links biology and geology. It provides strong evidences for evolution. It is crucial for stratigraphy and petroleum exploration. And most importantly, it helps to reconstruct the history of life. So this is all about our first video. To know more about the types of fossils, fossil nomenclature, check out the next video. Thank you.